Students, welcome to my channel. My name is Eddie. Once again, today we are looking at ionization energy as chemistry. So if you're new on this channel, think about subscribing and also comment below with a topic you'd love us to treat and also any question of your choice. Check the description. My WhatsApp number is there. Contact me and send me your assignment to be assisted. So get your pens and your book ready. If you know a friend you think this topic or this channel will be very beneficial to, kindly forward the link to them and the video so that they also benefit. So get ready and let's start. Alright, so what is ionization energy? I know you know the definition already. They are in your books. So today, as I said, my aim for chemistry is to explain concepts to you. So let's look at what is ionization energy. So if you hear me saying IE, I mean the very same thing, okay? This to help the conversation or the communication. So IE is the minimum amount of energy needed to remove the outermost electron from a neutral atom. You can write it down. The minimum energy needed to remove the outermost electron from a neutral atom. Okay, so for example, I have this is element X, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for element X, okay, for element X, this is the outermost electron. Okay, this is the outermost electron. Now we are saying that the energy I need to remove this electron from this neutral atom, that is ionization energy. Now let me explain it in a relatable language. So I want to ask yourself, how easy or how difficult it is to remove this outermost electron. If I say outermost electron, I mean the valence electron. Okay, how easy it is. So picture it in this way. How easy or how difficult it is to remove the outermost electron from a neutral atom. So once again, we're using these three to explain this concept, and also we'll be using atomic size to explain this concept. So if you haven't checked the video on atomic size, I'll leave the link in the description so that you check the video on atomic size and to help you understand this concept. So let's go. Right, so we are considering these two elements, element X, element Y. Element X has 3 shells, element Y has 4 shells. Once we look at which one will have a high IE and which one will have a low IE relatively. Okay, so now we will depend on these factors. So if you haven't checked my video on atomic size, kindly I'll leave the link in the description and you check it out because you will need this understanding here. So nuclear attraction is the attraction between the nucleus and the outermost shell electrons. This is the hidden effect is the impact of the number of shells on the nuclear attraction. Okay, which means that if the shells are more, there will be a stronger shielding effect. Now, affecting nuclear charge, as we explained it in the atomic size video, so you can check it out. Now, look at this. So, in layman terms, we are saying that we are checking which one of these cells will need to be easier to remove this electron. Which one of these will it be easier to remove the valence electron or the outermost electron? Which means if it is easier, then which means it will require a lesser energy. Okay, so we are saying that because this has 4 shells, okay, it has a lesser nuclear attraction. Because this has 3 shells, it has a relatively stronger nuclear attraction. So this has a smaller size, a larger size. Now, the one which does the attraction is the nucleus. Okay, and that's the same, which means that if it is easier to remove the electron here, then it should have a weaker nuclear attraction. Meaning, the weaker the nuclear attraction, okay, the easier it is to remove the outermost electron. Which also means that the weaker the nuclear attraction, the lesser the IE. But the stronger the nuclear attraction, the higher the IE. So here we have a lesser IE than here. So for example, if it takes as an example, I don't mean these are right figures. So let's say it takes 5 joules to remove this valence electron. It may take a higher joules, like 15 joules, to remove this one, because this one is larger in size than this, has a lesser nuclear attraction than this. Yes. Right. So we're looking at how IE will be faring on the periodic table. Okay. So across the period and down the group. Okay. All right. So across the period, okay, we are saying that atomic size decreases. The size becomes smaller and smaller across the period. This is due to the increase in nuclear attraction across the period, because the same number of shells, but there's an increase in atomic number. Okay, I explained that in my previous video, so you can check it out in the link below. Now we are saying that because there is an increase in nuclear attraction and there's an increase in size, more and more as you go along the period, it becomes more and more difficult to remove the outermost electron, which means that across the period there is an increase in ionization energy due to the increase in nuclear attraction and the decrease in atomic size. So take note, across the period there is an increase in ionization energy due to the increase in nuclear attraction, which means it becomes more and more difficult to remove the outermost electron as you go along, which means that this, comparing this and this, okay, oxygen and lithium, oxygen will have a higher ionization energy than lithium, because oxygen has greater nuclear attraction and a smaller size than lithium, meaning to become more difficult to remove an electron from oxygen than from lithium. Hope it's clear. Great. Then let's go down the group. So let's look at down the group. We are taking group 1: hydrogen, lithium, sodium, potassium. Hydrogen, lithium, sodium, and potassium. So let me help you out with the atomic numbers. Now, down the group, there is an increase in atomic size due to the number of shells. Okay, so 1 shell, 2 shells, 3 shells, 4 shells. So due to the number of shells, there is an increase in atomic size. Now, because there's an increase in atomic size, there is a lesser nuclear attraction down the group, which means the attraction between the nucleus and the outermost electron is lesser and lesser as you go down the group, which means that it will become more and more easier to remove the outermost electron as you go down the group, which means it will be easier to remove the outermost electron from potassium than from lithium. This is due to their weaker nuclear attraction, which means that K will have a lesser IE, Li will have a higher IE. That is down the group. So down the group, ionization energy decreases.